Okay, so good morning. Good to see folks again. I thought I'd start this day, as I often do at our boot camps, with a bit of a retrospective back on the previous day. Yesterday was a day of firsts with respect to many elements of the coverage material, and perhaps for many of you, with respect to your encountering of a variety of concepts. Broadly, the morning was a time where we reflected a little bit on data science and system science as traditions. And I advanced the somewhat provocative position that data science and system science, whilst each of them constituting a very rapidly growing and quickly advancing spheres of science of computational and informatic nature, they are oft pursued in isolation. They're very distinctive communities. There's very little bridging between them traditionally. And both as fairly young disciplines, there's been comparatively little encounters between these spheres of methods, although both are very computational in nature. And I advanced the provocative hypothesis that in fact, both of them are mutually compatible. Each can support the other. And secondly, that they are, in fact, in need of one another to achieve their full potential as fields of study. And during the day, there were a few specifics of those claims that I laid down. The claim that system science needs data science was pointed to on the basis of the fact that our system science models often involve a large number of assumptions that we need to ground. And we'll be seeing several specific ways in which we can bring together data from the data sciences side to inform these models when it comes to things such as parameter values of these models. But beyond that, there's going to be ways that we're going to begin exploring this morning at a certain level, and certainly in a central way this afternoon and tomorrow morning, where we use incoming data to not only estimate parameter values for the system science model, but to estimate its underlying state, the underlying situation with that model. And this reflects the fact that the system science models are models of an evolving situation. Many of you were familiar with that concept previously, but they're models that depict hypothesized processes that are operating in the world. And when we run them, we are positing some underlying evolution in factors largely unobserved from the world. And system science methods, well, they posit that often they benefit greatly from data which helps validate those assumptions and which can keep the model aligned with the situation in the external world. I argued that it's pointless or hopeless to view system science models as being crystal balls that will predict what will happen. Even the very best of models constructed with the finest of evidence at the time that it was built will inevitably diverge in its expectations from things in the world. There's many reasons for that. Some of them have to do with misestimation or simplifications in the model, things that it omits, things that it estimates but is off base, or things that will evolve over time themselves in terms of risk factors that right now we might have a good reading on, but it's going to change going forward. But another reason I pointed to yesterday is that there are stochastics in the world that no reasonable model could anticipate. Reasonable model with a boundary of significance could anticipate. And as a result, it's inevitable that with our system science models, that they will fall short of exactly predicting things in the world. But if we can keep them grounded in what is going on in the world, the particular sequence of factors we observe in the world, keep them aligned with that, they can be formidable tools for looking forward at any one time, because they've incorporated the latest evidence from the world, and they can be used to ask, okay, given where we're at, for example, what's likely coming down the pike, what policies or interventions at a case level or at a population level might be most efficacious. So we're going to see that system science can be informed by data science, not only in terms of pinning down some of the particulars of the assumptions captured in the model, but pinning down the model's depiction of the underlying situation right now to align it with the likely underlying situation from the world, so that the model is always kept current with the situation in the world, so it can look forward and give recommendations as far as choices that are most grounded and point to the most efficacious choices. So this is these are some ways in which data science informs system science. But we also saw glimmers of ways in which system science can inform data science, can inform our choices in data science. And there were several of them brought up in a scattered way. One was in response actually to a question Terry asked about the fact that we're always grappling with data quality issues when it comes to real world data. And there's a very real question, if we're to be data custodians of data in a certain area, how do we throttle our need to spend a lot of time in quality improvement and efforts to clean data, to scrub it in various ways, to impute missing values, to improve the timeliness with which that data is received. How do we triage the need to do that across many data sources with limited budget, limited time, limited resources? Where do we put our efforts when each data source could consume us in terms of trying to improve it and gather more reliable, more frequent data over time? And what I argued was that through a principle that Dan had actually mentioned of sensitivity analysis, we can actually inform an understanding on the data science side of which data items would offer the greatest bang for the buck, as it were, the greatest gain if we could improve them. And there's actually formalizations of this criteria in terms of value of information added if you were to, for example, improve the quality of one data source or another. But broadly, often our models will show that two different data sources, while each having perhaps some broad uncertainties associated with them, may have very different implications for our decision making, because uncertainties in one of them have a very big impact in shaping our understanding of which intervention, for example, strategy is best, where the other data source, perhaps it has the same level of quantitative uncertainty associated with it, same coefficient of variation or what have you, but it has very little impact on our choice of policies because the model is very insensitive insensitive to that degree of uncertainty. We'll see if we can illustrate this with some of our system science models. But when we're dealing with non-linear models, which is quite typical, often they will respond profoundly differently to variation in one type of data versus another. And so we could use that to throttle how much effort we put in on the data science side. Another way in which system science can inform data science was actually struck on within our final session there, which is where we saw actually system science models being used to create synthetic data sets that can be used to trial out different analysis strategies. But I argued, and I'd like to at some point show an example of this that makes it very concrete, that the patterns coming out of a dynamic model are plausible enough that they can often serve as a really good testing ground for particular analysis strategies to help us create analysis strategies that are more savvy, that are less likely to go awry in our inferences. Because in the dynamic model, in contrast to the world, we know the true underlying situation, and we can evolve analysis methods on the data science side, which are better at estimating an underlying situation as judged through the model. And those same improvements will often yield big gains in terms of analyzing real world data, the accuracy of those mechanisms. So that's another way in which system science informs data science. There's yet another way, which we'll be seeing in a further talk, likely on Friday, which is a profound one. And I'll just mention it here. It's again a provocative finding. Our own work has suggested that, it's not only suggested, I mean, it's clearly demonstrated that the types of data we're getting through these higher velocity data sources that we covered in the afternoon, things like data from wearable devices, things like data from social media channels or from search data, that extra level of resolution afforded by those data sources is not merely a luxury. It's not merely that it informs our models extra well and lets us ground our models especially well compared to traditional data sources. It's not just a nicety. It's actually something where if we don't have recourse to that sort of high resolution, high temporal resolution data, this frequent data points, we often, for certain types of analyses, we'll find that our analyses are off base. If we don't have that sort of high resolution, we'll often end up making the wrong conclusions about certain classes of problems. And our work has clearly shown that you could think of it as a variant of sensitivity analysis. If we have only access to a full set of data gathered, say, via smartphone-based tools, and compare that to our conclusions that we would come to if we had that full set versus if we had only a small set, say, data once a day or data once every half day, compared to every 15 minutes or every 5 minutes, we find that our conclusions start becoming very different and frankly incorrect with infrequent data. Whereas if we're getting the data every 5 minutes or every 15 minutes, the extra level of resolution there sharpens our understanding of what's needed and allows us to actually recommend things that are much more reliable. Okay, so this extra high velocity that we see is not merely a nice feature of these new data sets. For certain spheres of decision making, that's not all, but for certain spheres with certain real world situations, that extra level of detail makes a world of difference in terms of the reliability of our conclusions. Okay. I was just alluding to some ways in which data science informs system science and system science informs data science. Those are some reflections from the morning. The two benefit from each other. They're synergistic, but more than that, they need each other. I had then gone on in the course of the day to look at 3 higher velocity data sets that are of widespread interest and significance in the health science. And while not privileged, well, there's many other sources of data that we've used. For example, point of sale data that guides an understanding of how many people are purchasing, for example, a personal protective product on a daily basis that are very valuable. Those 3 types of data sources, data from searches, data from Twitter, and data from smartphones and wearables, are distinguished by the fact that they are broadly applicable, they're extremely flexible. You can look at search data related to influenza, you can look at it related to treatment seeking for opioid addiction, you can look at it related to dark web information seeking for drug-related activity. You can look at it for vaccination-related interests. It's very, very flexible. Similar data from smartphones and wearables. We saw yesterday the Ethica system allows us to create easily certain studies and deploy them on any of a wide range of topics. And indeed, the 75 to 100 studies Ethica itself has been applied to have been all over the map in terms of their focus. Similarly, Twitter data can give you insights into discourse online with respect to a wide variety of factors. And so these can be deployed for a wide variety of types of health subdomains. And they provide us with a high resolution picture of change over time with respect to many, many types of conditions. There were some questions that had come up with respect to those data sources. I had wondered about, in fact, many people had wondered, why we didn't see the baseline survey. I went back and saw that. You may remember 2 people, so I created a baseline survey and someone else created it, and I went and I deleted one. Turns out the other baseline survey that was created wasn't published. And so you have to publish it. I published mine before finishing it, but it looks like I deleted mine, and the other one wasn't yet published and had a little star next to it if we had looked. And that indicated that it wasn't finished and therefore wasn't yet operationalizable. When you're defining the study, you have to publish it. So that was the main issue there. And we saw how we could use Kibana to visualize some of that data. We're going to come back and loop around on this. Today is going to be quite lecture and case study heavy. We're going to be getting into particular methods. And I'm going to weave in another close pass on Ethica data because of the level of interest expressed in the surveys that you had circulated to me, pre-surveys for this event. In Ethica, we're going to try using it for a few additional items. Alex back there is working on a Bluetooth beacon. He's holding it up there, which we'll be using to show some of how Ethica interacts with the Internet of Things and wearable devices, so we can track the proximity of a person to a prosthetic limb, for example, they use to know whether they're using it on an ongoing basis, or a veteran to a service dog with which they're paired to know how much time they're spending with a service dog. We'll be seeing how Ethica could be used for that. We'll also be seeing some more features with Kibana, for example, creating word clouds of people's responses, GPS responses. We have a whole swag of GPS data that have come in now from people last night. A lot of fun to look at that, but also summarizing people's responses to surveys and looking at those in terms of how they responded to a particular question. Okay, so we'll come back to Ethica today. So that was a little bit of a retrospective on yesterday of where we're going to today. Broadly, we're going to be hitting on two methods. Number one is hidden Markov models, which serve as an extraordinarily useful technique for use with dynamic models. Strictly speaking, they are a dynamic model, but they're not arguably they're not a full system science model, but they're a very useful model for informing our system science models. And they are a formidable tool for pre-processing data in many cases. So we're going to be looking at those. Those will introduce us also and help reinforce some of the basic concepts. This idea of latent state. Our models depict not just observables, not just things where we happen to have data in the world, but the underlying processes that link those things, the latent factors where often we don't directly observe them, but they really shape what we do see. And for certain spheres involving mental health and addictions or substance abuse issues, for example, I would argue that it's almost impossible to talk about things without talking about these latent states as central. But I would argue the same is true for many sorts of health conditions. Things like hypertension, for example, often go unnoticed for many, many years in terms of symptoms and in terms of diagnoses, and yet it can be deadly. Diseases like diabetes often manifest in terms of somewhat higher glycemic levels over time. Even for things as obvious as communicable disease, there are long latent periods. Think about TB or think about types of communicable diseases where latent factors are central in terms of people shedding even during a latent phase. Or think about the immune system status as a latent variable, one of great significance, but one that's largely unmeasured. So we're going to see HMMs grapple directly with this idea of an underlying reality where we don't directly have data. In any one data point, any one piece of data is ambiguous. And yet we want to piece together a convincing picture and come to a conviction as to what's going on in the underlying system. The underlying system, as in our system science models, is evolving over time. So we're going to be dealing with HMMs both as kind of a very useful tool and as an exemplar for some of these basic principles that are at the heart of dynamic modeling. Secondly, we're going to be going on to a more powerful yet, but slightly more elusive query with particle filtering and dynamic models today. And I'm going to be giving a series of lectures that will help convey some intuition and increasingly quantitative understanding of what's going on in these models, whilst we're fortunate to have case studies by the new generation who sit amongst us in a very important set of contributions by which they're showcasing some of the features of particle filtering as applied to dynamic models. We'll also see an example on the front of hidden Markov models as a case study during this week, although it may not be today. Okay, so that's where we're going today. Any questions I can answer? Remember, my foremost commitment here is to make sure your interests and questions are addressed. So are there any questions we'd like to start with? Things we saw yesterday, things more broadly, philosophically, questions about the techniques. I'm glad to field any of them. Yes, Leon.
One quick question on Ethica. Does it handle mixed methods? Like if you're doing phone surveys and mailing surveys as well as, so you doing data entry into it as well?
Yeah, so good question. The answer is yes, but I'll answer it at two levels, okay? Number one, one of the hallmarks of Ethica, which we haven't yet touched on, but I plan to touch on, and some of the additional sections we'll be seeing to get people hands-on and doing things during the week is the fact that it supports data collection not only of when it comes to when it comes to sensors, the quantitative values, right? And whether it's proximity to a service dog, or in your case, a personal flotation device, say, or whether it's factors about people's location or level of physical activity. These are quantitative things. When it comes to surveys, a lot of them, survey instruments often will elicit some quantitative information through a visual analog scale, for example, that you could drag vertically or horizontally, through Likert scale questions, etc. But with those are often mixed in very different sort of information that often will tend to the qualitative. We saw yesterday photos, right? But often we have freeform text fields or freeform text where they can choose to either to type out the text or audio recording, which is in certain circumstances much more accessible. I'm imagining a lobster boat in rough weather. You know, you don't want to be typing things for an entry, but doing a bit of audio recording might be feasible. And for many Ethica studies, we draw on a set of responses that tap into qualitative responses. An example here is the SMART study. That's interesting. Okay, this is an interesting observation. I was going to show you an online website associated with a study. Tina, maybe you could, yeah, you might want to write about that, actually. But for some of our studies, there's narratives that are elicited from individuals within the study that help an understanding of qualitative context of a person. For example, reporting barriers to physical activity was the example I was going to show, where individuals might give a narrative description of barriers they've encountered. Maybe they submit it with a photo, sort of a la photo voice or something, but they're describing in their own words some of the challenges which prevent them from physical activity in the winter, let's say, here in Saskatchewan. And that data could be provided in a way that lends narrative context to the quantitative answers that are provided. This whole idea of eliciting narrative and qualitative responses mixed in with quantitative is one of the hallmarks of Ethica that quite a few studies tap into. So that's a kind of some mixed elements within a study. Now, when it comes to other sorts of data, like say from a participant, if you have data from additional types of information, say from mail-in or phone-based interviews or what have you, you can tie that in with Ethica data in basically two ways. One set is that Ethica is seeking to aggregate is not quite the right word here because it has multiple connotations, but here bring together data from other data sources into Ethica as a platform so that, for example, your data from Fitbit or Google Fit devices could be placed in and analyzed at the same time as other Ethica data. And data from surveys conducted via the web, not just phones, could be brought together in Ethica as a platform, which affords you to use Kibana visualizations or other things to analyze those. But for many types of other data externally, what we've done is typically link it in at analysis time outside of Ethica. So we use R quite a lot. Also, members of my group often we use other analysis ecosystems like the Python-based ones or Spark. But the point is, within any of these, there's a recourse to bring in other data sources and analyze them together with Ethica. Ethica, as we'll see, and I'll try to include it in one of our other sessions, allows you to download data from collected via Ethica. So you can download the data collected from surveys or collected from smartphones or what have you, from wearables. But more than that, you can actually connect, say, using a tool like R, a tool like Spark, or a tool like Python. You can connect to Ethica databases whilst you're connected to these other data sources and link them up and conduct analyses jointly with them without having to manually download Ethica data. And that's how we do a lot of analyses traditionally with these other data sources. And until recently, even Fitbit data, we've been conducting it by grabbing Ethica data from a tool like R, Spark, and grabbing these other data sources, say from Fitbit, and conducting those analyses outside of the Ethica platform. Now we can conduct them inside because Ethica has drawn in Fitbit data sources into its internal data storage for the same person. So that allows very handily for you to avoid the linkage issue of this participant ID over here in Ethica is the same as that participant ID on the Fitbit side or on the phone call side. It allows it to be done within Ethica. But where that's not possible, you can do it at the analysis time. Hope that's helpful. Yeah, great. Other questions I can address? Yes.
So I mean, I can access to Ethica via the API code, or I need to be inside to put my Spark platform to get the data.
So Ethica. So I'm going to engage in technical mumbling. Okay, so forgive anyone for whom this is off-putting. So Ethica is a platform which uses particular technologies. One of the many technologies it uses is a system called, for big data storage, called Apache Cassandra. Okay, so Ethica makes use of Cassandra data stores in addition to data stores using Elasticsearch search technology around Cassandra that forms the basis of Kibana. Ethica also maintains Postgres databases of some data in a more traditional relational database system, but the NoSQL systems represented by Cassandra are very important for scalability of analysis. In other words, to scale up to really large data analytics, what you get out of Cassandra is a much more performant solution than what you get with Postgres. And the Cassandra databases within Ethica can be queried from outside of the Ethica platform, okay? And we've done quite a bit of work with those databases using Spark, using the Cassandra connector from Spark. But you can use them from PySpark or the R Spark interface, and in principle you could use them from the Cassandra command line, etc. Now there are some asterisks here in terms of security protocols. So that data is right now behind a firewall at the U of S, okay, that we're accessing. But some of my students could show you how they access these databases from Spark to tap into the Ethica databases. It's a very straightforward thing with the Cassandra connector, and that allows very high efficiency in terms of human time as well as performance analytics to be conducted on Ethica, okay? I would suggest you talk with Tina over here, or you talk with Bo Poo there about analytics conducted through against the Cassandra databases directly. Tina's kind of the queen of Ethica study analytics right now. and she does a fantastic job. There are others in the room. Bo is doing a bunch of work with analytics, with physical activity accelerometer data, for example, right now, and he could also show you some things. Okay, yeah. There's some other students who may wander in, who I could also introduce you to. Janelle, who will be sitting here probably this afternoon. She's also extremely experienced for many Ethica analytics conducted. Okay.
So she's the second twin.
Sorry. Well, Tina's regality is her regal stature is particularly notable in her tapping of a Spark-based analytics against Cassandra. Whereas I think Janelle has done a lot of her analytics out of there, and I think what you're interested in is more within the reign of Tina there. So it's in her sort of domain. Yeah. So I'd suggest you speak to her, but several other students could also show you some basics.
Thank
you. Yeah. Okay, great. Other questions? So I'll engage now. I will cease my technical mumbling at that level at least, and we'll now ratchet back my geekiness. Okay, I'll try. Okay, other questions I can answer?
Good question.
Yeah.
Ethica, is there a cost to use it, or will there be a future cost to use it?
Yes, so it's a great question. So Ethica came out of, so Ethica technology started, the root of Ethica technology started in our lab in 2009, 2010. And we went through about 2 or 3 iterations of the underlying technology. So it actually started without smartphones. It started with wearable devices in the form of what are sometimes called sensor motes or wireless sensor systems. And we did some rather neat work, if I might say so myself, in the flu pandemic of 2009, 2010. Tracking contact patterns and relating that to patterns of flu transmission within a fairly sizable community. That work is notable in many regards, including some of the earliest publications on similar technologies tracking minute-to-minute contact patterns in groups. It's also notable for triggering a bomb scare at UFS, which is another story I can get into. The technology then switched over to smartphones and went through several iterations whereby the system was strengthened and enriched. And that was broadly, this whole series of projects was known as the IEPI project and was conducted by myself together with another faculty member, Kevin Stanley, who's in our department. Starting about 4 to 5 years ago, we started to get heavy requests to deploy Ethica studies for very large numbers of participants. We were being approached about running Ethica studies that were 10,000 people or more, with the prospects for growth to hundreds of thousands. And I felt increasingly uncomfortable having graduate students tasked with technical support for large studies of this. And a large fraction of our time was increasingly spent in what I would call service delivery for studies, software development, tasks specific to the study needs, technical support calls, efforts to customize study configuration in fairly straightforward ways that I didn't really feel were fully research tasks. It was more delivery operationally. And so we spun off Ethica about 4 years ago, maybe off, plus or minus a year there. So 4 to 5 years ago, we spun off Ethica to have a company associated with it. This is with the university's help. And the idea was the company would engage in service delivery. So they would handle the software development, they would handle the custom configurations, they would handle the support calls, and a lot of routine tasks associated with deployment. And we would handle more research questions. And that's the sort of relationship that you see today, with Ethica increasingly handling the vast bulk of sort of straightforward delivery of services. And we handle research question needs. And the hope always was with Ethica to get the computer scientists out of the loop as much as possible. In my view, it really inhibits innovation in the use of big data collection studies when you need to get a programmer to make each change to the system. And the hope was always there that rather than having programmers in the loop, you'd allow health scientists to modify things like this, and the system would just take care of that. And that's largely been realized as a vision, although around the edges, there's always needs to expand it more to handle things with additional flexibility, et cetera. And that part is going on, and Ethica is evolving as a platform to be more and more facile in delivering custom needs quickly, while still supporting with very high levels of quality a broad universe of possible studies. So it's a very general platform. So Ethica was spun off as a company. We're involved in many of these studies. Kevin Stanley's lab is involved in some studies we're not involved with. We're involved in some studies his lab is not involved with. Generally, we hew more to the health sciences side. He gets more involved with sort of urban planning type of interests, et cetera. Now, Ethica was, for a period, until about a year ago, about 1 to 2 years ago, Ethica was basically free for use, where you would pay for additional customizations on top of Ethica. The challenge there turned out to be, as you might expect, when you store data, when you store the volumes of data that come from something like Ethica, there's real costs associated with disks to store it, but more to the point, you have to purchase hardware, meaning servers, to serve up in response to the queries. So those things we were doing yesterday, querying data and graphing it or what have you, those sorts of things require computational resources. When you have large volumes of data to be fast, you need quite some computational resources. So Ethica began charging I think it's about 2 years ago now, maybe less a month. They began charging for certain size of studies. And they had a pricing calculator online until recently, which would basically allow you to say, okay, a study of this size running for this long, what's the pricing for it? And basically it's graduated by the type of data you're getting. If you're getting accelerometer data, that's big data. I mean, that's really high volumes of data. Bopu can tell you there's large amounts of accelerometer data, it's very high density, maybe thousands of measurements per second in some cases. And for that, they would charge quite a bit, whereas surveys, minimally. So we just had, a colleague of mine just put a grant today or yesterday where, it was for 40 people for 6 months or whatever. And I think for surveys alone, it's $800 or something like that. So pretty reasonable. So it's basically by participant week with a lower cutoff where it's free. So I think a study below something like 10 or 20 participant weeks is free. You can just go and deploy it and you're fine. So if you want to conduct a small pilot, no cost associated with that. But if you want to get to larger studies or to medium-sized studies, there's a cost per participant week. And then on the upper side, like they're running studies with thousands of phones, multiple studies with thousands of phones. the basic income study in the US Bay Area, I think is 3,000 people using Ethica now. There's another study which is ramping up, I think, to 8,000 to 9,000 people right now. And for those sort of studies, it's less cost per participant day because there's less in the way on a per person basis with technical support needs and so on. So there is a range in which Ethica is free. There's a range in which it costs money. And generally, if there's customizations needed, the question is, does the customization, is it going to be such a built-in feature of Ethica they're not going to charge for it, or will they charge some amount for the software development to put it in there in a timely fashion to extend Ethica? Let's suppose someone said, I want Ethica to support Apple Watches. I checked yesterday and they're not yet supported, but probably coming down the road. And if you said, I want Ethica to support Apple Watches for a study that begins next month, they'd probably say, okay, we can add that for $2,000 or something like that. And then that would be part of the ecosystem. Or, if we wanted to run a study with weight scales, a predecessor to Ethica was measuring data from weight scales via Bluetooth on an ongoing basis. If we wanted to get that added back into the latest version of Ethica, maybe that would be $500 and add that in because it's kind of along the lines of their future expansion. They do a lot of this custom stuff and then they try to fold it into the platform. So time use studies. How are people spending their time? That came out because of the basic income study, and then they have rolled it into the product as a whole. Similarly, answering questionnaires via browsers instead of via the mobile device. That's something they've rolled out. Another one is tracking goals, goal tracking for people as part of an app, for an intervention. They've added that functionality in to the product for certain studies, and they try to roll it into the platform as a whole. So the platform as a whole gets to include more and more stuff. Calendars were added about a year ago. Height and weight questions where the person could choose the units, kilograms and pounds. Those were added for a study and have become part of the standard platform. So I hope that's helpful in judging sort of how that all fits in. Generally, they try to be accommodating for things, and they try not to have it be a showstopper, the cost side. But at some point, the costs really add up. If you're dealing with thousands of people, there's inevitable costs for it to, answer your queries like that, which is what people expect. Other questions? Question?
Not a question, just a comment.
Okay. Yeah.
Just regarding the story you have just told me.
Yeah.
Like some type of data, like the velocity is just too high.
Yeah.
But like based on my experience, it doesn't need to be that high.
Yes.
For example, like the accelerometer, like of course if you want to like do the step count yourself or classify the type activities, then you might need the fine grained resolution of accelerometer. But all the type of sensor like pedometer or the wind display, the light, ambient light or the GPS. I feel like the collecting mechanism is rely totally on the interruption mechanism of the phone, which is extremely high, and like usually like things don't change that fast. So it would be better if there is a filter mechanism to discard the samples that is not necessary.
Yeah. Well,
it saves you a lot of velocity and volume.
Yeah. Yeah, and this gets into the point of how much data do we need, and broadly that depends on the research question, and you've alluded to it, right? I mean, if you're seeking to do activity recognition, if you want to know is someone walking, so we've done quite a lot of work with accelerometer data and hidden Markov models, which I'm actually about to discuss, in classifying, for example, is someone sitting, standing, walking, running, or actually the more operative one was sitting, standing, lying down versus other types of activity? Or are they in a vehicle or not right now? Or are they indoor or outdoor? Or is the phone even being carried by them or not? These are important distinctions when it comes to many types of interests. And for there, detailed accelerometer data is excellent, that can really allow us to pin down, oh, this person is sitting versus standing, which for some studies is of interest. By contrast, for many studies, pedometer data, just a pedometer count is of interest. I know with Andrew's study, for example, where you're working with some of the data, that study was at a time, I think before, I'm not even sure Ethica had a pedometer sensor stream at the time that was created. I can't remember which.
They added like a year ago, like the study started 2 years ago, so where we want to have the pedometer at the time. But since last year, like the data started.
Yeah.
So, but my point is like there is no option to set the sampling rate of the data set. And of course, since I know the value, both the volume and the velocity will take a toll on cost syndrome. So, and since we need to pay that, like at least in the future or something like that, so have an option to kind of say, okay, I don't need that much. So it will release the cost for like the researcher.
It's true, and this gets into how much is needed, and I will argue that it is. You're right. It's dependent on the research question. It would be nice if you could throttle it back. One of the challenges there is that a lot of what we encountered in our early work with the IEPI project that gave rise to Ethica, a lot of the issue at that point was balancing battery consumption versus the ability to collect rich data. And the realization was that if we weren't really careful about how we collected the data, the battery of the phone could be drained extra quickly. And people are not going to want an app on their phone if it halves their battery life, right? If I can't go through the day anymore with my phone without it, going to zero battery, I'm not going to want that app on me. It's negative value being added to me by it. And so what Ethica chose to do was to standardize how frequently data was collected according to what the phone's internal mechanisms made most efficient. And so this so-called duty cycle of Ethica, where it's collecting data every so many minutes for a certain amount of time, that comes directly from the desire to minimize the power consumption added by Ethica. And it can be criticized, and you could certainly say some of that data could then be thrown away because you don't need to collect as much. And I think that's a fair comment. Even if you were to adhere to that regimen of power sipping behavior, you could probably throw away some of that data. You could triage it at time of data collection. And I'd suggest that you advance that as a suggestion for more sophisticated researchers. They could say, I only want, 1 out of every 10 samples, for example, retained for accelerometer. But increasingly what the Ethica has tried to do, and what Mohammed, as the head of it, has tried to encourage people to do, is to think twice. Do they need accelerometer and gyroscope and very detailed traces of data? If so, for a study of significant size, they're going to pay for it more. And so there's kind of that mechanism to throttle it back. You only want to pay for it if you really need it. And it consumes a lot of data. For studies out there that use accelerometer together with other data, it's accelerometer data. Something like 80% of all data collected is just accelerometer traces. And you're right, in most cases, it's not needed given the research questions advanced by that researcher. But that takes a certain level of sophistication, the researcher, to have conviction of that, so they say, I don't need it ahead of time. Okay, any other questions? Okay, so can we get into hidden Markov models? What do you think? Okay, cool. Let's do it. So I'm just going to stop my recording for this, and we'll go on to the first lecture of the